Hi guys, welcome to Easy Math.
In this video, we are going to discuss about the third type of the simplex method to solve the LPP. Okay. Here, if any one of the BI is negative, what's meant by the BI? It is the right hand side of the constraint. Okay. If any one of the BI is negative, then you have to multiply -1 on both sides of the constraint to become the right hand side positive. Okay. If any one of the BI, that is the right hand side of the constraint, is negative, means you have to multiply -1 on both sides of that constraint to become the right hand side positive. Okay. Let us discuss the problem. Solve the following LPP using simplex method. Maximum f is equal to x1 plus 2x2 plus x3 subject to 2x1 plus x2 minus x3 less than or equal to 2, minus 2x1 plus x2 minus 5x3 greater than or equal to minus 6, 4x1 plus x2 plus x3 less than or equal to 6, and xi greater than or equal to 0 for I is equal to 1, 2, 3. That means x1, x2, x3 greater than or equal to 0. Okay. Here the right hand side of the second constraint is negative. Therefore, you have to multiply -1 on both sides of the second constraint to become the right hand side positive. Okay. While multiplying -1, this greater than or equal to inequality becomes less than or equal to. Okay. The objective function is of maximization type and the first and third constraints are less than or equal to type only. All the non-negative variables are positive only. Okay. Here the right hand side of the second constraint is negative. We multiply -1 on both sides of the second constraint to become RHS positive, right? Hence a given LPP becomes, you have to simply write the objective function as it is, that is maximum f is equal to x1 plus 2x2 plus x3 subject to the first constraint is also same as that. Right hand side of the second constraint is negative, therefore you have to multiply -1 throughout the second constraint. While multiplying -1, here -1 into -2, it becomes 2x1. While multiplying -1 with x2, we are getting -x2. While multiplying -1 with x3, it becomes minus into minus plus 5x3. And the greater than or equal to sign becomes less than or equal to into -6, that is plus 6. Okay. The third constraint, you should write it as it is, that is 4x1 plus x2 plus x3 less than or equal to 6, and the non-negative variables xi greater than or equal to 0 for I is equal to 1, 2 and 3. Okay. Here the objective function is of maximization type and all the constraints are of less than or equal to type and the non-negative variables are positive. So we have to introduce 3 slack variables because there are 3 constraints, right? Therefore, first one you have to introduce S1 to the first constraint, S2 to the second constraint and S3 to the third constraint. Okay. Then you have to write the standard form of the LPP. The standard form of the LPP is given by maximum f is equal to x1 plus 2x2 plus x3 plus you have to introduce S1 plus 0S2 plus 0S3, right? Subject to the constraint, first one you have to introduce S1, right? Therefore 2x1 plus x2 minus x3 plus S1 plus 0S2 plus 0S3 is equal to 2. The cost for the slack variable S1 is 1 and the cost for the remaining slack variables are 0. Second constraint, here we are going to introduce S2, right? Therefore, the cost for the slack variable S2 is 1 and the remaining slack variables S1 and S3 becomes 0. Therefore, 0 S1 plus S2 plus 0 S3 is equal to 6. We are introducing the slack variable S3. Therefore, the cost for the slack variable S3 is 1 and the remaining slack variables S1 and S2 becomes, the cost becomes 0 plus S3 is equal to again 6 and you have to write all the variables x1, x2, x3, S1, S2, S3 all are greater than or equal to 0. Okay. Now we have to move on to the initial basic feasible solution. How we obtain the initial basic feasible solution? By putting x1, x2, x3, that is the non-basic variables x1, x2, x3 is equal to 0 in these three constraints, and get the basic variables as s1 is equal to 2, s2 is equal to 6 and s3 is equal to 6. Now we have to proceed on with the initial iteration. This initial iteration, the initial basic feasible solutions are s1 is equal to 2, s2 is equal to 6 and s3 is equal to 6. Okay. Now you have to write the first constraint. What are the coefficients? 2, 1, minus 1, 1, 0, 0. And for the second constraint, 2, minus 1, 5, 0, 1, 0. And for the third constraint, it is 4, 1, 1, 0, 0 and 1. Okay. Now, you have to write the cost for the variables s1, s2, s3 from the objective function. What are they? There are 0, 0 and 0. Okay. Now, we have to perform the fj star minus cj. Since in this problem they are mentioning it as the objective function is of maximum f. Therefore, we are using fj star here. Okay. By multiplying the cost with the xb column, that is 0 into 2, 0, plus 0 into 6, 0, plus 0 into 6, 0. Therefore, the value is 0. The cj values are from the objective function. Maximum f is equal to x1 plus 2, x2 plus x3 plus 0 s1 plus 0 s2 plus 0 s3. Okay. 0 into 2, 0, plus 0 into 2, 0, plus 0 into 4, 0, minus 1, that is minus 1. Again 0 into 1, 0, plus 0 into minus 1, 0, plus 0 into 1, 0, minus 2, that is minus 2. For the third variable, 0 into minus 1, 0, 0 into 5, 0, plus 0 into 1, 0, minus 1, that is minus 1. And for the next variable s1, 0 into 1, 0, plus 0 into 0, 0, plus 0 into 0, minus 0, that is 0. For this variable s2, 0 into 0, 0, plus 0 into 1, 0, plus 0 into 0, 0, minus 0, it is 0. And for the third variable s3, 0 into 0, 0, plus 0 into 0, 0, plus 0 into 1, 0, minus 0, we are getting 0. Okay. Here, the fj star minus cj value is less than 0. So, you have to choose the most negative value. What's the most negative value here? Minus 2. Therefore, the variable x2 enters the iteration. Okay. String variable is x2. You have to find which variable exits from the iteration or which variable leaves the iteration. For finding that, you have to find the ratio. Okay. How you have to find the ratio? Here, look at this pivot column. One value is in negative. So, you need not find the ratio for the second row. Okay. Just you have to find the ratio for the first and the third row. Is it clear? Finding the ratio value, have to divide xb column by the corresponding column coefficient, that is 2 by 1, that is 2. And for the third row, 6 by 1 is 6, right? Then you have to choose the least value. Then you have to choose the minimum value from these two ratios. What is the minimum value here? 2. Therefore, the leaving variable is S1. Leaving variable is S1. Okay. You have to encircle that. Hence, the pivot element is 1. By using these three values, we have to find the first iteration table. Let us take this as R1, this is R2 and this is R3. Okay. Here we are taking this as R1 dash, R2 dash and R3 dash. Since S1 is a leaving variable, you have to replace S1 by that entering variable X2, right? Therefore, we have to find the X2 row first. That is R1 dash is equal to R1 by the corresponding pivot element. The pivot element is 1, right? Therefore, this becomes R1 by 1, that is 2 by 1, again 2 by 1, 1 by 1, minus 1 by 1, 1 by 1, 0 by 1 and again 0 by 1. Therefore, we are getting 2 by 1 is 2, again 2 by 1 is 2, 1 by 1 is 1, minus 1 by 1 is minus 1, 1 by 1 is 1, 0 by 1 is 0 and again 0 by 1 is 0. Okay. Now we have to find the second row, that is R2 dash. How we get the R2 dash? R2 dash is equal to R2 minus the corresponding column coefficient, that is minus 1, right? Therefore, minus column coefficient into R1 dash. That can be written as R2 minus into minus plus R1 dash. What is R2? 6, 2, minus 1, 5, 0, 1, 0. What is R1 dash? 2, 2, 1, minus 1, 1, 0 and 0. You have to add these two rows. Therefore, while performing the addition, we are getting 6 plus 2 is 8, 2 plus 2 is 4, minus 1 plus 1 is 0, 5 minus 1 is 4, 0 plus 1 is 1, 1 plus 0 is 1, 0 plus 0 is 0. Therefore, R2 dash value is 8, 4, 0, 4, 1, 1 and 0. Okay. Now, we have to find the R3 dash value. R3 dash is equal to R3 minus the corresponding column coefficient, that is 1 into R1 dash. Okay. This can be written as R3 minus R1 dash. What is R3? That is 6, 4, 1, 1, 0, 0, 1. And what is R1 dash? 2, 2, 1, minus 1, 1, 0, 0. We are going to subtract these two rows. Therefore, 6 minus 2 is 4, 4 minus 2 is 2, 1 minus 1 is 0, 1 minus minus 1, that is 1 plus 1 is 2, 0 minus 1 is minus 1, 0 minus 0 is 0, 1 minus 0 is 1. Therefore, the R3 dash value is 4, 2, 0, 2, minus 1, 0, 1. Now, you have to write the cost for the variables x2. What is the cost? 2. What is the cost for the variables s2 and s3? That is 0 and 0, right? Now, we have to find the xj star minus cj. 2 into 2, 4, plus 0 into 8, 0, plus 0 into 4, 0. That is, you are getting 4. 2 into 2, 4, plus 0 into 4, 0, plus 0 into 2, 0, minus 1, that is 4 minus 1 is 3. Next, 2 into 1, 2, plus 0 into 0, 0, plus 0 into 0, 0, minus 2, that is 2 minus 2 is 0. Again, 2 into minus 1, minus 2, plus 0 into 4, 0, plus 0 into 2, 0, that is minus 2, minus 1, that is minus 3. Next, 2 into 1, 2, 0 into 1, 0, plus 0 into minus 1, 0, that is 2 minus 0 is 2, right? Then for the variable s2, 2 into 0, 0. Plus 0 into 1, 0. Plus 0 into 0, 0. Minus 0, that is we are getting 0. For the S3 variable, 2 into 0, 0. Plus 0 into 0, 0. Plus 0 into 1, 0. Minus 0, therefore we are getting 0. Here, at least one fj star minus cj value is less than 0. You have to choose the minimum value, but already there are only one negative value. So, you have to choose the variable x3 as the entering variable. Okay, you have to encircle this. This is the pivot column. X3 is the pivot column. Therefore, the entering variable is x3. Now, we have to find which variable going to leave the iteration. For that, we have to find the ratio. If any negative value lies in the pivot column means you need not find the ratio, right? Therefore, you have to simply find the ratios for the S2 and S3. That means that for the second row and third row. Okay. Here we have to find the ratio by XB column divided by the corresponding column coefficient, that is 8 by 4 is 2. And again for the S3 variable 4 by 2 is 2. Okay. Here the two ratios are same. So you can choose which variable going to leave. I am choosing the S2 variable. I am choosing the S2 variable. Therefore, the leaving variable is S2. You have to encircle this. 4 is the pivot element. Therefore, the pivot element is 4. Okay. By using these terms, you have to move on to the next iteration. Since the fj star minus cj is less than 0 in both the iteration, that is from in the initial iteration as well as in the first iteration, the optimal solution is not obtained. So only we are proceeding with the next iterations, right? Here this is R1 double dash and this row is R2 double dash and this is R3 double dash. Okay. Now here the leaving variable is S2 and the entering variable is X3. Therefore, we have to replace S2 by X3, right? And you have to find the X3 row first. That means first you have to find the R2 double dash. How you find the R2 double dash? R2 double dash is equal to R2 dash by the pivot element. What is the pivot element here? 4. That is 8 by 4, 4 by 4, 0 by 4, 4 by 4, 1 by 4, 1 by 4 and 0 by 4. What are the values? Here 8 by 4 is 2, 4 by 4 is 1, 0 by 4 is 0, 4 by 4 is 1. 1 by 4 is 1 by 4. You have to maintain the fraction. Okay. Again 1 by 4 is 1 by 4. 0 by 4 is 0. Okay. Next you have to find the R1 double dash. R1 double dash is equal to R1 dash minus its corresponding column coefficient. What is that? Minus 1 into R2 double dash. This can be written as R1 dash minus into minus plus R2 double dash. What is R1 dash? 2, 2, 1, minus 1, 1, 0, 0. What is R2 double dash? 2, 1, 0, 1, 1 by 4, 1 by 4 and 0. Here you have to perform the addition operation. While performing the addition operation, we are getting 2 plus 2 is equal to 4, 2 plus 1 is equal to 3, 1 plus 0 is equal to 1, minus 1 plus 1 is 0, 1 plus 1 by 4 is 5 by 4, 0 plus 1 by 4 is 1 by 4, 0 plus 0 is 0. Therefore, the R now R1 dash can be written as 4, 3, 1, 0, 5 by 4, 1 by 4 and 0. Next we have to find the S3 row. Okay. R3 double dash is equal to R3 dash minus its corresponding column coefficient 2 into R2 double dash. What is R3 dash? 4, 2, 0, 2, minus 1, 0, 1. What is R2 double dash? 2, 1, 0, 1, 1 by 4, 1 by 4, 0, right? While multiplying 2 with R2 double dash, we are getting 2 into 2, 4, 2 into 1, 2, 2 into 0, 0, 2 into 1, 2, 2 into 1 by 4, 1 by 2, 2 into 1 by 4, again 1 by 2, 2 into 0, 0. You have to perform the subtraction here. While subtracting, we are getting 4 minus 4 is 0, 2 minus 2 is 0, 0 minus 0 is 0, minus 2 is 0, minus 1 by 2 is minus 3 by 2, 0 minus 1 by 2 is minus 1 by 2, 1 minus 0 is 1. Now we are going to substitute the values R3 double dash. What are the values? 0, 0, 0, 0, minus 3 by 2, minus 1 by 2 and 1. Now we have to write the cost for the variables x2, x3 and s3 from the objective function. What is the cost for the variable x2 and x3? 2 and 1. What is the cost for the variable s3? It's 0, right? Now we have to find the value fj star minus cj. That is 2 into 4, 8. Plus 1 into 2, 2. Plus 0 into 0, 0. That is 8 plus 2 plus 0, that is 10. And 2 into 3, 6. Plus 1 into 1, 1. Plus 0 into 0, 0. 6 plus 1, 7. 7 minus 1, 6. 2 into 1, 2. Plus 1 into 0, 0. Plus 0 into 0, 0. That is 2 minus 2, 0. Then 2 into 0, 0. Plus 1 into 1, 1. Plus 0 into 0, 0. 1 minus 1, 0. Then 2 into 5 by 4, 10 by 4. Plus 1 into 1 by 4, 1 by 4. Plus 0 into minus 3 by 2, 0. That is 10 by 4 plus 1 by 4, it's 11 by 4. Minus 0, that is 11 by 4. Next value, 2 into 1 by 4, 2 by 4. Plus 1 into 1 by 4, 1 by 4. Plus 0 into minus 1 by 2, 0. That is 2 by 4 plus 1 by 4, it's 3 by 4. Minus 0, that is 3 by 4. Next one is 2 into 0, 0. Plus 1 into 0, 0. Plus 0 into 1, 0. 0 minus 0 is 0, right? Here, all the fj star minus cj values are positive. Therefore, we obtain the optimal solution here. Fj star minus cj greater than or equal to 0. Therefore, the optimal solution is given by maximum f is equal to 10, x2 is equal to 4, x3 is equal to 2, and here x1 value is not obtained, therefore x1 is equal to 0. This is the optimal solution for the given problem.
Thank you for watching. Don't forget to like, share and subscribe. Bye guys.